A lot of time when we solve a system of linear equations, we ended up with what's so-called a dependent system. So I'm not going to cover in this video what a dependent system is, but in this video we're going to learn how to parameterize the solution of a dependent system. So I'm assuming that anyone viewing this video already understood and knew what a dependent system is and how to come to at least some solution. Let's now look at what we have here, a system of two linear equations. So we have 2x plus 5y equals 8, and the other equation in our system is another linear equation being minus 4x minus 10y equals negative 60. So after anyone taking steps to solve this system of equations, we're going to end up with, and I'm sure we're going to end up with one equation in its most reduced form, being a 2x plus 5y equals 8. And the other solution is simply just 0 on the left-hand side equals 0 on the right-hand side. Or in other words, this is really just one equation. And briefly, this is a reminder of what a dependent system means. And so in this case, to make it easy, why don't we just simply write that down as only one single equation? So our remaining single equation here is 2x plus 5y equals 8. So my aim in this video lesson, once again, is to learn how to parameterize the solution here. Basically, here we already have the solution, but we want to parameterize the solution. And now parameterizing this final solution, this final equation, can be done in two different ways. One way, we're going to let x equals x. It seems a little strange, but the intention here is x can be chosen independently. So x equals x really means, or intentionally means, x value can be chosen independently. And once we let x equals x, or meaning x value, any x value can be chosen independently, then I had another video lessons how we can solve this equation for y in terms of x. So let's get it done here. So once x equals x, this equation here, 2x plus 5y equals 8, I can subtract 2x from both sides. And that brings me into a 5y equals minus 2x plus 8. And I am going to divide both sides by 5. And so that 5 is also going to get divided into each of my terms here throughout the equation. And so consequently, I'm bringing my equation down to a final expression, y equals to minus 2/5 x plus 8 over 5. And so at this final formula here, what I have done is I have expressed y as a variable. I have expressed y as a variable, but the key word here is dependent on the chosen value for x. So remind yourself that x here can be chosen independently. So you can let x equals 5, you can let x equals 2, you can let x equals negative 10, but the y value here must be calculated dependently on x value. And so doing it this way, this is our solution to the dependent system, and that's why it's called dependent system. One variable is dependent on the other variable. And here's how we parameterize y in terms of x. And just as I said earlier, this final solution, general solution of our dependent system can be solved, can be parameterized in two ways. So one way we already finished. The other way is to now let y equals y. So we've learned a little bit of experience here. Y equals y is to intend that y value can be chosen independently. And so once we let y can be chosen independently, then here our remaining responsibility is to solve for x in terms of y. And so starting with our equation again, 2x plus 5y equals 8. And here I am going to subtract 5y from both sides of my equation. Then consequently I'm reducing down to 2x equals minus 5y plus 8. And further, I am going to divide both sides by 2. And this brings my equation into a final expression. X equals minus 5 halves y plus, and 8 halves can be reduced down to 4. So this final expression here, on one hand, I see that as I'm expressing x as a variable dependent on they're all variable, but x here is now as a variable but dependent on y. So remind yourself, we let y be chosen randomly, be chosen independently, but now the value for our x variable must be dependent on what we chose for y. And to calculate the value for x, we have to go with negative 5 halves times the value we chose for y plus 4. And this is also how I can say that from the general solution, 2x plus 5y equals 8 from a dependent system. This is how I parameterized the solution of x in terms of y. And so now looking back into what I said earlier, at this point when we came down from reducing our system into only one, this final equation has already been referred to as the general solution. The general solution to this dependent system. And what we stepped further into was re-expressing this general solution into one form, y equals minus 2/5 x plus 8/5. And this equation now, it's the same equation as the other one, but this form, this expression of our general solution is now referred to as, it's the general solution again. But parameterized. In terms of x. meaning we're treating x as the independent variable and the y variable here as the dependent variable. And the other expression we turned into was x equals minus 5/2 y plus 4. So this is also another way of writing the general solution, and this time I'm calling this, it's the general solution. It's the general of the dependent system, but parameterized in terms of y, meaning we're letting the y variable be the independent one. We can choose an independent value for y, and the value for x comes out dependently on the value of y.